All right, here we go. Law of cosines. Last videos that we had were law of sines. Now we do the law of cosines. This will be a little quicker. My opinion is if you can use a law of sines first, do that. It's usually less work, or at least the formula is smaller. But if you're stuck because you don't have enough information to use the law of sines, then you have to do the following. And those three formulas that you'll see, and they are directly related, or at least they look like the Pythagorean formula. I'll show you what I'm talking about. So you see the law of cosines right here. If I cover out that part right there, that's basically the law, the Pythagorean formula right there. A squared plus B squared is equal to C squared. You can see that part right there. So there's an adjustment to that because it's not a right triangle. So this piece is the adjustment. So and there's a cosine, so therefore law of cosines. I'm not developing this for you today. I'm just giving you the result of someone else smarter than me having come up with a formula that it works. So again, I'm not developing it today, I'm just using it. So if it says if we're given two sides and an included angle, or if we're given three sides of a triangle. Now when I say two sides and an included angle, here's a triangle. Let's say I was given two sides right here. The included angle would be this one here, not these two. It would be, that's the two sides and included. Sometimes they call it side, angle, side. This is side, that's the angle, and that's side from left to right. Or if you're giving three sides, of course, you don't have any way of getting the angles if you have three sides. But this is the formula we're going to use. And I grabbed this image, of course, you can see it. I'll give not kudos, but acknowledgement to what looks like the mathwarehouse.com. All right, here's an illustration. We've got a triangle with three sides. I want to find, let's say, angle C. Let's find angle C. So what I'm going to do is get my blue pen. If I want angle C, and by the way, that notation right there, there's a typo, mathwarehouse.com. That should be a capital C in my opinion. So I'm going to make that a big C right there. I want to use this one. If I'm going to find C, I want to use this one. I just have to decide where the C, the little sides are. And of course, you guys know we're going to identify this as little c, this is little a directly across from angle A, and this is little b. So if I want to find this one, I'm going to use this formula right there. So here we go. Little c squared is equal to little a squared, which would be here, and adding that little b squared, and I'll subtract 2 times the a, again write down the 9, and the b, and we go cosine, and I don't know the angle, big capital C, don't know. And so our job now is to find C. We get rid of all these numbers right here, and be very careful, easy to make a careless mistake. You cannot, well, you can push these together, but you can't go 25 and subtract 2. You can't do that. So what I'm going to do is I'm going to make this 64 first. 25 minus 2. Okay, 9 times 5 is 45, so I'll make that 45. I'm going to subtract these guys. Well, let's add them together first. I'll show you that. Add these two together, that's 106. Multiply these, that's minus 90. Okay, you can't subtract those. That's a careless algebra mistake. I'm going to move the 106 to the left. So subtract 106, 64, subtract 106. I'm not going to take a chance and do that in my head. I'm going to go 64 subtract 106. Okay, so that's negative 42. Okay, now how to get rid of the negative 90, but that's multiplied right here. I'm going to divide both sides by negative 90. So that's negative 42 divided by negative 90 equals 42 divided by 90 equals cosine of C. I'm not going to worry about simplifying that because really all I need to do is do cosine inverse to both sides and I get the C. So capital C is equal to cos inverse of 42 over 90. And my calculator's result, you gotta make sure you're in degree mode. Second, so that's cos inverse of 42 divided by 90. And I'm getting about 62, let's do 2 decimals, 62.18. So angle C right here is about 62.18 degrees. So that's how to find that angle. And if you wanted to find angle B, you do very similar. You do the same thing if you wanted to. And if you want to find angle A, you could do the same thing. Or once you start the cosine, law of cosines, you can jump right into the law of sines and finish up the problem. What did I just say? Well, I have an angle right now. It's an approximation, but I have an angle at least. I could use law of sines to finish up the problem. Law of sines requires that I have a corresponding angle and a side, which I do now. So then I can find angle A using law of sines. And once I find angle A, then all I have to do is add up those two angles and subtract it from 180 degrees to find the last one. Yeah, so that's the strategy. Usually you have to use the law of cosine once, and then you can find the rest of the pieces after that with law of sines. Okay, for the most part, that's all you have to do. So I'm going to bypass any of the other examples and go right to the word problem. So again, I'm not going to do this one. This is just like the previous one. 3 sides. This one here is a little different. Maybe I should do this one actually, because it's got 2 sides and an angle. So I'll do this one, but I'm not going to do that one. And then we'll do the word problem. So find side Z right there. I want to find that right there. Now, the law of cosines, if I'm wanting to find, let's say Z, let's call it some other angle. Let's call it, find a, make this a Z. Make that a Z. So this would have to be the angle Z right here. See that? So just replace this with Z's. So Z squared is equal to the other 2 sides squared. The other 2 sides squared is right here, 6.5 squared plus 9.4 squared minus 2 times 6.5, 9.4, and it's cosine of the angle 131. So these two are related to each other right here. And so now it goes Z squared is equal to, simplifying this, gosh, this is just a matter of putting it all on your calculator. And eventually we're going to take the square root. So how about this? Z is equal to plus minus, but sides of a triangle are never negative. So plus the square root of all this. And I'll just type it in my calculator the way I see it. And 9.4, and a cosine of 131 degrees. And here we go. Get that little square root on there, and as I type, that square root symbol just kind of stretches right out. Square that puppy, and then go plus 9.4 squared, and then subtract 2 times 6.5 times 9.4 times cosine 131 degrees. And I know I'm in degree mode from a previous problem. Okay, 14 point, again, 2 decimal places, let's say 5.2. So this is squiggle, squiggle, 14.52. Not hard, not hard. Okay, now the word problem, and then we'll be done. Word problem. Another bearing problem, looks like. 2 ships leave port 4 in the afternoon. Okay, so here's the port down here. And looks like that's the north, south. Of course, you know this is west over here. One is headed at a bearing of north 38. Probably put a little degree marker on there. 38 degrees east. There it is. Traveling at 11.5 miles per hour. Okay, remember that. The other's traveling at 13 miles per hour. Here's its bearing. Okay, southeast is right here. How far apart are they when the dinner is served at 6 p.m.? They want to know the distance here. Now here the key is, how long have they been gone? 2 hours. So you're going to take the speed and multiply it by 2. So 11.5, A is equal to, what is that, 23 miles. And B is at 13 miles per hour, that's 26. And I want to find this distance right here. You know this angle now, because that angle is the leftover 180 degrees. So 180 degrees, subtract the 38 and the 47. Uh, 95. Now it's a straightforward law of cosines. And I'm wanting the distance, so we want d squared is equal to, and then you take the sum of the squares of the other distances. So the sum of the squares of the 26 and the 23, and you subtract 2 times those 2 distances, the product of them, and it's the cosine then of the angle, which is 95 degrees. So just like the last time, I'm going to go d equals the square root of all that. Not even simplifying this, because I can type that right in my calculator. So second square root. Enter. Answer 36. Let's say the nearest miles. 36 miles. That one wasn't so bad. That law of sines that I did in a previous video, that took some time because I had to draw the darn picture. Okay, there you have it. Law of cosines. Until next time, be safe.